Electronic, Mr. Daniel Büth. Are you there yet?
Yeah, hello
Yes.
everybody.
Hello, Mr. Büth.
Thank you for joining us. How are you doing today?
I'm pretty fine, thank you.
Great.
Perfect.
So today you will be speaking about traffic applications. And I have a short introductory question for you if you're ready.
Yes, of course, please.
So you've been working for Fike Electronic for 15 years already. During this time, I'm sure the vehicle identification must have changed a lot. Can you give us a quick feedback on the milestones during this time?
Yes, of course. So when I started my career with Fike, we were operating already RFID-based systems for vehicle identification, but the technology was quite different in comparison to the current ones. At that time, mainly LF technology was the state of the art for vehicle identification. For sure, very reliable and comfortable for the people, but yeah, it brought different challenges with it. On the one hand, it was more difficult and complex to install the technology, as loop antennas must be placed somewhere in the street, for example. Transponders must be mounted under the car. And now more and more this changes towards more comfortable systems like HF or UHF technology, where you either need to present your card, your access control card in front of a reader, or even with UHF technology, much more comfortable, you place just a transponder in the windscreen of your vehicle, and then by means of long-range UHF reading by reader, compact reader, combines reader and antenna that is mounted on a pole, the transponder is read already from a longer distance, and the barrier system can be opened for vehicle access control already in advance, so the cars don't need to stop in front of the barrier.
All right. So
Yeah.
Definitely some developments were made. Yeah.
Yeah, for sure. The technology progressed very well, and for sure, next to RFID, there are also other identification technologies in place meanwhile. But I think this is something I can show you during my presentation also.
Yeah, I would say we'll get the presentation started right away. So we'll let you share your screen.
Yeah. So,
That's it. Perfect.
yeah, you can see my screen? Okay, perfect. Then I will start, and yeah, welcome everybody to my today's presentation, Smart and Secure Traffic Applications. What makes traffic smart and secure? I think this is a very good question. And from my personal point of view, it's everything that contributes to make life of the people more comfortable and easy, and for sure that contributes to protect our environment. This can be investments in the infrastructure, it can be investments in new technologies, or even an update of existing processes. So in the end, there are different factors that must come together and must interact with each other to achieve the optimum results. Within the following 30 minutes, I would like to give you a brief overview what our company and the technologies we are providing can contribute to realize such kind of applications. Please allow me in the beginning to give you a short overview on our company. So Fike Electronic was founded in the year 1966 by Mr. Fike himself, who is still the sole owner of our company. We are a German-based company located in the city of Weilburg, that's in the center of Germany, in the north of Frankfurt. We're operating two further facilities and subsidiaries here in Germany. We have a sales office in Cologne and a development office in the city of Bad Hersfeld. And next to this, another subsidiary in the United States in the city of Atlanta. Meanwhile, we have approximately 400 employees and achieved a turnover of 61 million euros in the year 2019. The development and the production of our products is located in Germany only. So we have our own electronics manufacturing here in our company. And in case we need to work with external suppliers, we typically choose companies coming from our region. So we have short ways for interaction and communication with our suppliers. Our core focus is on the quality of the products that we provide, that's for sure. Within our company, we are operating 4 different business units. We have a division that is called controllers. Here we are developing and manufacturing gate and barrier control systems. With these controllers, we can control any kind of gate or barrier system, starting from sliding doors, barrier systems, or even big doors at the airport, the hangars for the airplanes, for example. Then we have a sensors division where we are developing and manufacturing induction loop detectors used in the traffic applications for control of the traffic lights, for traffic counting, vehicle classification, or a security system in parking applications. Within our identification division, we provide RFID and barcode systems for identification. Here we are one of the suppliers that can provide solutions for all the common passive frequency bands like LF, HF, and UHF. In all the different frequency bands, we can provide a wide range of different products, starting from small reader modules, which are suitable for integration into machines, printers, or any kind of devices, for example, medical devices, to ensure patient safety connections are carried out in the right way, or that only original and sterilized equipment is used. The product range reaches over mid-range readers up to long-range devices, which we will also see here in the presentation, that allow read ranges of 10 meters, 15 meters, or even more. The youngest division within our company is the department payment, where we are developing and producing fully certified contactless payment terminals, with which we are mainly addressing unattended payment applications. So you will find it also everywhere in smart cities, for example, in the sector of the public transport, in validators inside the buses and trains. So you use your credit card to check in, check out when entering or leaving a bus and a train. Or you will find it on ticket machines, vending machines, park meters, and anywhere where unattended payment is possible. When we are looking a little bit more detailed to our identification division, this is the department to which I belong, we are active or selling our products mainly to 4 different target markets. We have the logistics market, which is quite important for us. Then we have the sector of healthcare. We learned a lot about it already in the morning. Then we have the libraries, also can be part of smart cities, where we contribute with our products for an comfortable library management and an automated rental systems. Belonging to this, there are also applications that can be found in museums for interaction with the visitors or guidance systems for the visitors. And finally, another important market for us is the sector of AVI, automated vehicle identification. And to this market, we will step in now, and I will give you, hopefully, a good overview on what we are doing there and what can be possible with the technologies we are providing. In the first step, I would like to split the market of automatic vehicle identification a little bit down in different categories. On the one hand, we have the vehicle access control, where we find applications in the parking sector or in perimeter protection, access control and security, for example, controlling the access to companies or company parking lots, buildings, or whatever. Then we have the sector of tolling systems, where we have either stationary tolling systems, where the vehicle must stop in front of the barrier, gets identified, or the toll fee gets paid, and then the barrier opens. or we have multi-lane free-flow tolling systems. And for sure, also the sector of traffic with the smart city applications like inner city protection, for example, to identify vehicles, to control the pollers and open the access to the inner city areas, for example, and the traffic management, of course. Why is this market so special for Falk Electronic? I told you already about the 4 different divisions that we are operating. And within the vehicle access control sector and AVI market, we have synergies between all the different divisions. This will be clear when we're looking to the components of such a vehicle access control system. So on the one hand, we have the inductive loop detectors. This is used in a vehicle access control system on the one hand to check for the presence of a car, but also a security system to identify vehicles parking under the barrier and to prevent the barrier closing while a car is standing there. Then we have the identification technology to identify the vehicles and the people maybe inside the vehicle. And for sure, we also have the gate and barrier control systems to open and to control the opening and closing of the barrier. And in addition, in private or public operated parking applications, where a fee needs to be paid, also our payment terminals can be seen and can be used. For the induction loop detectors, we have one device available or 2 different devices available, detectors from our MNE series. These are available either with as 1-channel or 2-channel detectors, and they allow a reliable detection of the vehicles, an easy installation and setting via dip switches, and advanced settings and diagnostics via special software. In general, the detectors allow a high level of flexibility as they support a wide range of AC and DC supply voltages, a wide temperature range in which they can use. So it doesn't matter if you install it somewhere in the Nordics, in Alaska, or whatever, where you have very low temperatures, or even in the desert in Dubai or whatever, where you have high temperatures, the device can manage all of it. Then you can adjust the sensitivity, and the device is so intelligent that it executes an automatic retuning and adjustment of its frequencies if the loop becomes detuned, for example, due to environmental influences. And also a direction indication and identification of the direction is possible with the 2-channel detector, so you can distinguish between ingoing or outgoing vehicles. A suitable door control unit from us we see on that picture, on that slide. And the very special thing about that one is that it allows a smooth starting and braking of the barrier system or door system. So it starts very smooth, then it's opening very fast and closing very smooth. And for sure, that allows a high level of material protection and long life cycle time of the motor and all the mechanics that are connected to it. It's also easy to install, and it allows parallel operation of 2 barriers or doors. For example, if you have a double-leaf folding door, or even a 2-barrier system on a very wide street or entrance to an area. We have various inputs, outputs available to connect the induction loop detectors, to give trigger signals from identification technologies from the readers, for example. When we are looking now to the reader technologies and identification technologies, focusing on RFID, I mentioned already in the beginning, we have 2 different possibilities how the identification could be handled. On the one hand, we have the wide range identification based on a UHF system. So in that scenario, the transponder is sticked into the windscreen of the car. A long range reader is installed on the side of the street, and it is able to identify, to identify the vehicle already in several meters in front of the barrier system. If access is granted, the barrier is opened, and it is possible to let the car passing by without stopping in front of the barrier system. Another alternative, if you don't want to realize it in that way, it's also possible to use a system based on HF technology, NFC technology. In that case, typically a smart card reader is installed in a column on the side of the lane. The vehicle approaches to the barrier, the car needs to stop. The driver either needs to present its access control card or its smartphone maybe, and the NFC chip is read and validated, and if access is granted, the barrier is opened. So yeah, completely, or here we offer fully flexibility, and in the end which technology is used is depending on the preferences of the operator. For long-range identification, we have a very interesting product. It's our UHF compact reader. It combines reader and antenna in one housing and allows read ranges of up to 10 meters. Due to the circular polarization of the antenna, it can read tracks in all orientations. By means of a second antenna, of an external antenna connector, it's possible to control also a second lane with just one reader. That for sure contributes to reduce the hardware and installation costs. Inside the reader, we have already an integrated signal light with the colors red, green, and blue to interact with the user and to give the driver of the car an optical feedback if access is granted or denied, or if a transponder was identified successfully. The reader comes in a robust and weatherproof housing, so is suitable for direct outdoor installation, and due to its feather mounting capability, it is very easy and fast to install. Inside the reader, we provide a secure element. That is quite important when thinking about high security application. So that is a very secure memory bank in which we can store the different application keys for reader and transponder authentication. A suitable product for proximity reading is our CPR50, for example. That is an IP-based access control card reader where we can ensure an encrypted transfer of information via Ethernet connection. It can either be operated in a polling mode, so the access control application requests information from the reader, or we operate it in a so-called notification mode. In that reader mode, the reader works permanently, searches for cards, and if a data set is detected, or if a card is detected, data set is transmitted to a predefined IP address. The access control unit checks the access rights and gives the reader feedback if access is granted or denied. This is visualized in an optical way to the user, and optionally we have a relay card available that can be controlled by the reader to open the barrier system. From these two reader types that I've shown you, different versions and variants are available. So on the one hand, we have devices that are suitable for vegan communication. So if you have an external access control unit, we have devices that can be connected via vegan interface to it for wide range as well as for proximity reading. Then we have the online systems with Ethernet interface available, and very special and very smart even for smaller access control applications or for applications that are installed in a little bit longer distance away from the main buildings. We have products from our My Access series that can work as complete standalone access control devices. So these readers combine reader technology as well as access control unit and a database in one device. You have the possibility to store the data sets of up to 5,000 users directly in a secure memory of the reader. And if a card and a transponder is detected, the reader executes a comparison of the red transponder data with the information inside its database and decides whether access is granted or denied. Next to RFID, there are different other identification technologies in place. For example, to open a barrier or a gate or a door, a radio transmitter can be used. It's also possible that you have a PIN pad. You get your access code via email or via SMS, for example, and need to enter it on the PIN pad at the entry point. It's also possible to do an identification of the user via barcode technology, which you have received in advance, or also optical system, an automatic license plate recognition and analysis of the license plate. That, for sure, are alternatives to RFID. One issue with all that different technologies is that they are mainly basic, sometimes insecure, and also easy hackable. And why this is the case and how RFID can contribute to solve that issue and to realize really high security applications, we can show you in the following video.
There's a wide variety.
What is the best vehicle access control system? There are a number of methods used for vehicle access control, but what is the best? Radio transmitters, keypad, barcode, license plate recognition, RFID. Gated communities, corporate and fee-based parking facilities spend mightily on gated access control systems. Ironically, the majority of installations use the most basic, insecure or easily hackable methods to grant access. Keypad pins are often shared. Radio transmitters such as garage door style opener signals can be sniffed and retransmitted. License plates and barcode tags can be simply photographed and easily reproduced. None are secure and each are easily defeated. Only one technology, RFID with UCODE DNA, has a cybersecurity protocol with the speed of radio frequency identification system for security. A UCODE DNA RFID tag placed on a vehicle is encrypted to the highest data security standard, and tags cannot be sniffed or reproduced. FIG Electronics Vehicle Access Control Readers uses UCODE DNA and compatible with other RFID-based protocols. The FIG RFID reader provides fast, long-range detection to keep vehicles moving, compatible with any existing access control panels, easy installation, accurate, reliable performance. Contact fig-electronics.com to learn more.
Okay, I hope you can see my screen again. So in that video, we learned about a special transponder type, UCODE DNA. So that is a new transponder chip developed from NXP, and that one allows a secure key storage inside the transponder and a secure authentication of reader and transponder. In that way, we can ensure that a tag is not cloned and that only authentic tags access will be granted to an area or to a building, for example. One example where we have used that technology can be found in the city of Moscow, where one of our partners has realized access control to different skyscrapers in the inner city. They used a UCODE DNA transponder that is placed into the windscreen of the different cars, and in that way, a secure authentication and fast and reliable access is granted to the different parking areas of the skyscrapers. they saw a significant improvement in the waiting times. Traffic jams were reduced and access was granted much faster to the different buildings due to the long-range identification. So it was not necessary for the people to stop in front of the barrier, to show a card to an NFC reader, or to order a ticket from it. We have published a complete case study about that project, which you will find on our website, fike.de, if you're interested in further information about that project, how it was realized, and solution that our partner and we provided to it. Last but not least, to complete the parking sector, we have also some payment terminals in our product range. All of them are based on our platform CVAN Plug. CVAN Plug is a payment terminal module that offers you a high level of flexibility. You can either integrate it into your housing, into your own systems, so you have full design flexibility with it. Next to it, we have a so-called modular kit that allows you to retrofit already installed park meters and ticketing machines with it. We have also a CVAN box available with an integrated display for user interaction, or a PIN pad to be used in applications where the payment needs to be authenticated and verified by entering a PIN. The next sector of the smart traffic applications is electronic toll collection. Here we have different kinds of applications and tolling scenarios. It can be privately operated or even public operated toll plazas. You will find toll points typically at bridges, at tunnels, or on highways. Here we need to distinguish between stationary tolling and free-flow tolling applications. Also here, different technologies from us are used. We have the payment terminals that can be used. We have the door controllers, induction loop detectors, and also RFID as one possible identification technology. In general, in most of the tolling applications, we will find one of the following 4 technologies. On the one hand, we have ANPR systems, so automated number plate recognition. We have also DSRC systems in place for dedicated short-range communication. Here we have an active transponder that is given to the driver or as assigned to a car and installed inside the car. Or we have a system called GNSS, where we use satellite navigation technology for following a vehicle on the toll roads and to calculate and estimate which distance has been traveled. And finally, we have the RFID technology. For sure, all of these different technologies have advantages and disadvantages. ANPR, we have seen in the video, a number plate can be easily copied. On the other hand, identification of the number plate does not work if there is a lot of dirt or ice in winter times on the license plate. Then it is nearly unreadable. DSRC systems are working reliable, but the technology is quite expensive, and you have also active transponders inside the car. These are also more expensive and not maintenance-free. So after a certain period of time, maybe half a year or even a year, the battery needs to be replaced. On that time, RFID is getting more and more popular for tolling applications as well, for several reasons. On the one hand, it's a technology that is available worldwide and already used worldwide in a wide range of different tolling applications. It's easy to use and to distribute. In comparison to other technologies, the hardware costs and operation costs are very low. The transponders are maintenance-free, so we have passive transponders without any battery inside that are just sticked into the windscreen of the car. The technology is independent from external influences and can identify either vehicles or persons without optical features. So that If there is any dirt on the windscreen, it doesn't matter. The transponder is also readable without any direct side connection. With the new technology that we have seen in the video, the WIOT DNA, copy-protected and tamper-proof solutions are possible. We can support applications in stationary tolling, then it's similar to a parking system, but also free-flow applications. The technology is very environmental friendly, and if a transponder is installed inside the car, it can be used for a wide range of further applications next to the tolling. It can be used for access control to parking areas, to companies, or to charge the parking fees in public parking lots, for example. Also for traffic management and to count traffic in certain places, to measure times, how long a vehicle takes to enter from one point of the city to another, for example. Typically, for tolling applications, our UHF long-range reader LAU 1002 is used. This is a 2 watt reader with 4 antenna ports, a high receive sensitivity, and allows read ranges of 12 meters or even more, depending on the used transponder. We have various interfaces available for host communication, inputs, outputs to connect induction loops for triggering, or a signal light for interaction with the user. Also here we have the secure element inside and various possibilities for reader transponder authentication, and that for a very excellent price performance ratio. In conjunction with that reader, we offer different kind of external antennas. For example, our antenna 290-290 or 580-290, which we see here on the top. All of these antennas are circular polarized, coming in a robust housing, are suitable for direct outdoor use and allow an easy installation. The antennas distinguish with their reading zone and the antenna beam width in which they are transmitting. The antenna 290 on the bottom radiates a field in an angle of 65 degrees times 65 degrees, while the big antenna has a much more focused reading zone of 65 degrees times 30 degrees. And how these different antennas can be used, we will see on the following slides when we're looking to the installation. So typically in a tolling application, the antennas and readers are mounted on a gantry in a height of 5.5 meters to 6 meters approximately. So that is the typical height of it. And that way you can allow a secure identification of any kind of vehicles, cars, trucks, bicycles, or whatever. The best practice has shown us that the antenna inclination should be about an angle of 10 degrees. So when we're looking now to the different tolling scenarios, we will see the advantages of the different antenna technologies. In a free flow application, which we see on the left side, you never know on which lane or in which position a vehicle is passing by. So here it is very important that we have overlapping antenna fields. In that case, our 65-degree antenna is a big advantage, as we see that all the different antenna fields are overlapping and we can cover the complete width of the street and make sure that a car will be identified or a vehicle will be identified in any position on the track. If we go into a stationary tolling system, typically the lanes are separated from each other. So here it is very important that we are just focusing on the particular lanes to make sure we are reading the transponder from the car that is standing in front of the barrier system. And here the 30-degree antenna is a very big advantage. By means of that antenna, we can contribute to minimize the risk of cross-lane readings. So it means that the car that is standing here in the middle lane, for example, the tag does not get identified from the antenna that is assigned to the left or right lane of the middle lane, for example, and that the tag would falsify open the barrier for one of that cars parking standing in front of it. Some references and projects, success stories that we have realized can be found here in Germany, for example, at the Warnow Tunnel in Rostock, where several lanes, 11 lanes, are equipped with our reader technology. Also, a very interesting project was the Mersey Gateway Bridge that links the cities of Manchester and Liverpool with each other. That bridge was the biggest infrastructure project in the recent years within the United Kingdom. The bridge was inaugurated by the Queen herself, and the tolling system that was installed there by one of our partners was awarded with the Excellence in Tolling Award. And last but not least, we are a proud participant in the National Highways tolling project in India, where meanwhile much more than 1,000 readers have been installed over the entire country. In general, what can be expected in the future for tolling? So I think that attended toll plazas will disappear more and more in the future. There is definitely a trend towards free flow applications or open road tolling, and that will be becoming the main mode of operation in the future. The payment will become cashless, either by credit card, presenting it to a terminal, or even you are a registered user, you're getting a UHF tag, a transponder, or transmitter, or whatever inside your car, and then you will be charged at the end of the day, of the month, or whatever period of time. In general, I expect that the harmonization will be fostered by policy, and that there will be a strong collaboration between public and private stakeholders. All of them have different interests, and it will be very important to combine them with each other. And I think they are on a very good track to realize that. RFID, from my point of view, will become more and more important. It is already very well established in many regions of the world. Currently in Europe, DSRC systems are the state-of-the-art technology, but also here there are several activities ongoing. For example, RAIN founded a new work group to drive the adoption of RFID advanced road charging technology, especially here in Europe. So it will be very interesting to see and to follow the developments in the future and where the way is going to. And so with this slide, I have reached the end of my today's presentation. Thank you very much for your attention, and yeah, we'll be happy to answer your questions.
Thank you very much for giving this insightful presentation today. Before we open the questions for the chat, I have a question for you. Regarding the future trends, you mentioned that you believe that the attended toll plazas will disappear more and more. Yeah. In your personal opinion, when do you think this trend will be finished, or which country would be first to finish attended toll plazas?
So in general, it will be an ongoing process for sure over the next years, and it will still last a very long time until this process is finished. In general, it depends a little bit on the technology that is used. When, if even attended toll plazas will be in place. So when you look to Germany, for example, we have already a tolling system in place for trucks, and you don't see any toll gates or toll barriers for attended tolling anywhere on the road. So here the process is more or less finished. On the other hand, when looking to other countries, it will be very important, to raise the awareness of the people about that new technologies, to make them aware of the possibilities and the savings that they could have due to that new technologies, that they save time, that there will be less traffic in front of the toll barriers when they register for one of the available systems, or even if they pay by credit card.
Okay, yeah, thank you for that answer. So I think we will open the questions to participants and see what is at the chat already. The first one, can smartphones be used as well instead of smart cards for the access system?
Yes, that's possible, of course. So typically all the smart card readers support the NFC technology and NFC communication as well. And it's also possible to use your NFC-enabled smartphone to register for access and to store that information into a database.
A lot of smartphone questions
today.
today, but it makes sense. We are running around with the smartphone anyway,
For
so
sure.
absolutely. Friedrich, any more questions? Here it is. You mentioned that the loop sensor recognized when they were not functioning properly. Is this, in this case, do they automatically send a signal as a call for maintenance?
In that case, it is possible to raise or to switch an output signal to make the people and the maintenance personnel aware that something is going wrong, that either the loop is broken or that is permanently detuned or whatever, and that there is a fault on the loop. Yes, that's possible. So we'll get informed immediately within a certain period of time that can be configured until the output signal is raised.
Okay.
Any more questions from the chat? Yes. For the solutions you presented, there are a high number of RFID labels in use. Is the current chip shortage a problem to carry out current access control projects?
Up to date, I'm not aware of any problems in the supply of transponders. For sure, there is also an impact that can be recognized when we that the lead times may be increased, but in general there is a bigger demand at the moment for transponders recognizable on the market in general. So from my point of view, I think that the impact will be not too big, that projects can be realized as scheduled.
Okay, perfect. So good news. All right.
But we are a reader manufacturer, not a tech manufacturer. To be honest.
Yeah, but good news that
it's
all the
and the feeling that I'm having from the market at the moment, what I'm getting about.
Okay, so here's already the next question. Has there been a general increase in roads, access areas, or tunnels with toll systems?
Yes, I think that it is a topic that is getting more and more important, that the number of applications is increasing, also due to the fact that many roads, tunnels are meanwhile privately operated, and for sure these people want to get paid for the services and the infrastructure they are providing. And especially from the private sector, I think that there is definitely an increasing demand for it.
All right, that makes sense.
Yeah. That was the last question. So thank you very much for your time and for presenting today.
Yeah, thank you as well, and for giving me the possibility to present our solutions at your event.
Perfect.
Thank
Have
you.
a nice day.
See you. Bye.
Yeah, you too. Bye-bye.